Namaskar. Today we are going to study congruence of triangles. We all have seen numerous traffic sign boards that look exactly the same. Traffic sign boards are examples of congruent triangles in action. We know that a closed figure formed by three intersecting lines is called a triangle. A triangle has three sides, three angles, and three vertices. In triangle ABC, AB, BC, CA are the three sides. Angle A, angle B, angle C are the three angles, and A, B, C are three vertices. We are familiar that two copies of photographs of the same size are identical. Similarly, when we place a 1 rupee coin on another coin minted in the same year, they cover each other completely. What such pairs of figures are called? They are called congruent figures. Congruent means equal in all respects, or figures whose shapes and sizes are both the same. Let us draw two circles of the same radius and place one on the other. What do we observe? They cover each other completely, and we call them as congruent circles. Let us place one square on the other with sides of the same measure. We observe that the squares are congruent to each other. Do you know why we study congruence? Let us try to understand. We have numerous examples where congruence of objects is applied in our daily life situations. If triangle ABC is congruent to triangle PQR, we write triangle ABC is congruent to triangle PQR. When triangle ABC is congruent to triangle PQR, then sides of triangle ABC fall on corresponding equal sides of triangle PQR, and so is the case for the angles. That is, AB covers PQ, BC covers QR, CA covers RP, angle A covers angle P, angle B covers angle Q, and angle C covers angle R. Also, there is a 1:1 correspondence between the vertices. That is, A corresponds to P, B corresponds to Q, C corresponds to R, and is written as A corresponds to P, B corresponds to Q, C corresponds to R. We need to keep in mind, under this correspondence, triangle ABC is congruent to triangle PQR. But it is not correct to write triangle ABC is congruent to triangle QRP. In congruent triangles, corresponding parts are equal, and in short, we write CPCT for corresponding parts of congruent triangles. Let us draw two triangles with one side 4 centimeter. Are these triangles congruent? No, they are not congruent. Now, let us draw another two triangles with one side 4 centimeter and one angle 50 degrees. Are they congruent? We see that they are still not congruent. So, equality of one pair of sides or one pair of sides and one pair of angles is not sufficient to give us congruent triangles. What would happen if the other pair of sides of the equal angles are also equal? Let us take BC equals QR equals 4 centimeter, angle B equals angle Q equals 50 degrees, and also AB equals PQ equals 2 centimeter. Now, what can we say about congruence of triangle ABC and triangle PQR? In this case, the two triangles are congruent. The equality of two sides and the included angle is enough for the congruence of triangles. This is the first criterion for congruence of triangles. Two triangles are congruent when they are exactly the same in shape and size. There are some criteria for congruence of triangles: side, angle, side, angles, side, angle, side, 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 and right angle, hypotenuse, side. Angle, angle, side criterion for congruence of triangles is a particular case of angle, side, angle criterion. Let us now state the first criteria for congruence of triangles. Two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. This result cannot be proved with the help of previously known results, and so it is accepted true as an axiom. Now, let us construct two triangles whose sides are 4 centimeter and 5 centimeter, and one of the angles is 50 degrees, and this angle is not included in between the equal sides. Are the two triangles congruent? No, the two triangles are not congruent. For triangles to be congruent, it is very important that the equal angles are included between the pairs of equal sides. So, side angle side congruence rule holds, but not angle side side or side side angle rule. Next, let us try to construct two triangles in which two angles are 60 degrees and 45 degrees, and the side included between these angles is 4 centimeter. Overlapping these triangles, what do we observe? We see that one triangle covers the other completely. That is, the two triangles are congruent. We observe that equality of two angles and the included side is sufficient for congruence of triangles. This result is the angle side angle criterion for congruence and is written as ASA criterion. Let us state and prove this result. Since this result can be proved, so it is called a theorem, and to prove it we use the SAS axiom for congruence. We can state the second criterion for congruence of triangles as two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of another triangle. Let us prove it. We are given that in triangles ABC and DEF, angle B equals angle E, angle C equals angle F, and BC equals EF. And we need to prove triangle ABC is congruent to triangle DEF. For proving the congruence of the two triangles, three cases arise. Case first, let AB equals DE. Then side AB equals side DE is assumed, angle B equals angle E is given, and side BC equals side EF is given. So, triangle ABC is congruent to triangle DEF by SAS axiom. This case is proved. Case second, if possible, let us assume that AB is greater than DE. So, we take a point P on AB such that PB equals DE. Now, in triangle PBC and triangle DEF, PB equals DE. By construction, angle B equals angle E is given, and BC equals EF is given. So, triangle PBC is congruent to triangle DEF by SAS axiom. So, angle PCB equals angle DFE, but we are given that angle ACB is equal to angle DFE. So, angle ACB equals angle PCB. Is this possible? This is possible only if P coincides with A or BA equals ED. So, by SAS axiom, triangle ABC is congruent to triangle DEF is proved again. Case third, if AB is less than DE, take a point M on AB extended such that MB equals DE. Now, in triangle MBC and triangle DEF, MB equals DE by construction. Angle B equals angle E is given. BC equals EF is given. So, triangle MBC is congruent to triangle DEF by SAS axiom. So, angle MCB equals angle DFE CPCT. But we are given that angle ACB equals angle DFE. So, angle ACB equals angle MCB. This is possible only if M coincides with A or BA equals ED. So, triangle ABC is congruent to triangle TEF by SAS axiom. Hence proved. Thus, ASA congruence theorem is proved in all the three cases. Now, suppose in two triangles, two pairs of angles and one pair of corresponding sides are equal, but the side is not included between the corresponding equal pairs of angles. Are the triangles still congruent? We observe that they are congruent. Can we reason out why? Since the sum of the three angles of a triangle is 180 degrees. So, if two pairs of angles are equal, then the third pair is also equal. So, two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. This is called AAS congruence rule. Now, let us draw different triangles with angles 40 degrees, 50 degrees and 90 degrees. How many such triangles can we draw? In fact, we can draw as many triangles as we want with different lengths of sides. These triangles may or may not be congruent to each other. So, equality of three angles is not sufficient condition for congruence of triangles. Therefore, for congruence of triangles, out of three equal parts, one has to be a side. Let us state the third criterion for congruence of triangles. If three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. Also, let us state the fourth criterion for congruence of triangles too. If in two right triangles, the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. Let us construct a triangle in which two sides are equal to 3.5 centimeter and the third side is equal to 5 centimeter. What is such a triangle called? A triangle in which two sides are equal is called an isosceles triangle. So, triangle ABC is an isosceles triangle with AB equals AC. Now, let us measure angle B and angle C. What do we observe? We observe that in each such triangle, the angles opposite to the equal sides are equal. Let us now apply the criteria of congruence of two triangles to prove a theorem. Angles opposite to equal sides of an isosceles triangle are equal. We are given an isosceles triangle ABC in which AB equals AC and we need to prove that angle B equals angle C. Let us draw the bisector AD of angle A. For the proof, we may proceed like this. In triangle BAD and triangle CAD, AB equals AC is given. Angle BAD equals angle CAD by construction and AD equals AD is common. Therefore, triangle BAD is congruent to triangle CAD by SAS rule. Therefore, angle ABD equals angle ACD by CPCT. That is, angle B equals angle C. Hence proved. Is converse also true? That is, if two angles of any triangle are equal, can we conclude that the sides opposite to them are also equal? Let us construct a triangle ABC with BC of any length and angle B equals angle C equals 50 degrees. Draw the bisector of angle A and let it intersect BC at D. Overlap the two triangles by folding it along the side AD so that vertex C falls on vertex B. What can we say about the sides AC and AB? The side AC covers side AB completely. So, AC equals AB. So, the sides opposite to equal angles are equal. Let us prove it. We can state the converse of the previous theorem as the sides opposite to equal angles of a triangle are equal. We are given in triangle ABC, the AD is the bisector of AD, angle A. We need to prove that AB equals AC. Let us prove. In triangle ABD and triangle ACD, angle ABD equals angle ACD is given. Angle BAD equals angle CAD by construction, and AD equals AD is common. Therefore, ABD is congruent to ACD by ASA rule. Therefore, AB equals AC by CPCT. Hence proved. Let us solve some problems. Two figures are congruent if they are of the same shape and of the same size. If two triangles ABC and PQR are congruent, under the correspondence, A corresponds to P, B corresponds to Q, and C corresponds to R. Then symbolically it is expressed as triangle ABC is congruent to triangle PQR. If two sides and the included angle of one triangle are equal to two sides and the included angle of the other triangle, then the two triangles are congruent. SAS congruence rule. If two angles and the included side of one triangle are equal to two angles and the included side of the other triangle, then the two triangles are congruent. ASA congruence rule. Angles opposite to equal sides of an isosceles triangle are equal. Sides opposite to equal angles of a triangle are equal. If three sides of one triangle are equal to three sides of the other triangle, then the two triangles are congruent. SSS congruence rule. If in two right triangles, hypotenuse and one side of a triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. RHS congruence rule. That's all for today. Namaskar.